We will now go over study problem 6-1 from our textbook. We are given an investment, a security you might say, and with various states of the world. Actually 4 states of the world are provided with different probabilities, and related to each state of the world we have different outcomes or rates of returns. And the question is first of all asking for the expected rate of return on this investment, which is the easy part. The hard part is to figure out the standard deviation on this investment. So obviously we have a scenario analysis, and we will use these different states of the world, different scenarios, to come up with the averages. And obviously it will be a weighted average that we are considering. So let's have a look at the expected return. So I will create an additional column to the right side, and in that column, if this is column 1, this is column 2, I will call it column 3, which will be simply column 1 times column 2, basically probability times return, every individual return in each case. So let's start with the first row, the first state of the world. With 10% chance, our return will be minus 10%. We will lose our investments, a portion of our investment. So that would give us 10% of 10% would be 1% loss, minus 1%. In the second state of the world, with 20% chance, we will make 5% return. So that would be equal to 20% times 5%. It's again 1%, but this time it's a plus 1%. The third scenario, so we're already done with the first two. Now we're in the third one. 30% chance, we'll get 10% return. You multiply these out, you get 3%. And finally, the fourth state of the world, 40% chance, we'll get 25% return. Should probably give us a 10% positive return. And we have these products for each state of the world. All now we need to do is to add these up. Obviously, the first two outcomes will just cancel each other out, and we will be left with a 13% return on our investment, and that would be considered as the expected return of our investment. Is it reasonable? Yeah, let's see. We realize the probability distribution, so these are the probabilities and these are our various returns, and roughly the average of these numbers should be close to between 5 and 10%, huh? You would say initially, but later on you realize that more weight is associated with this outcome here, so that tends to take your average closer to that number. In that case, the 13% that we just found is quite reasonable. Now, next step, we need to figure out the standard deviation. So I create a new column here. This time the column should represent the first column, the probabilities multiplied by individual returns, so the numbers we got from the second column, minus the average return. Let's just say ER, right? So that's the notation that we use. So let's just say ER squared. So that's not easy, huh? So we need to be careful here. Let me write down the very first line here, what we would get. So the probability is 10%, so 10% times the individual return here is 10% minus 10%. You know what, I'll just leave the percent sign here because I don't think it will cause any issues. Minus the average return is 13%, and we need to square this. Making this calculation, minus 10 minus 13 is minus 23. Minus 23 will be squared. The minus sign will disappear. We will have 529. And with a 10% further multiplication, that should come out as 52.9%. And we can continue to do similar things here. So 20% chance, our return will be 5%. The average is 13%. And we square it. 5 minus 13 is 8, minus 8 squared is 64. 20%, 1/5 of 64 is 12.8%. For the third row, we have 30% chance that our return will be 10%. The average return does not change again, it's 13%. 10 minus 13 is minus 3, minus 3 squared is 9. 30% of 9 would be probably 2.7%. And finally, with 40% chance, our return will be 25%. Average return did not change, it was squared, so 25 minus 13 is 12. 12 squared is 144. 40% times 144, we get 57.6%. Now we can add up these numbers, and I believe it should be 126%. That should give us the variance of this probability distribution. But we really need the standard deviation, so the question makes it specific that that's what we need, the standard deviation, which is basically the square root of that 126. Taking the square root, we realize the answer to be 11.22%, and that should be the final answer. Let's just step back for a minute and try to make sense of what happened. So we have different states of the world, they add up to 100%, right? So we are quite aware of that. And for each different state of the world, you can think of states of the world as a recession, normal economic conditions, boom, and very, very extraordinarily good conditions. So those 4 states are associated with 4 likely outcomes, and we are to figure out an expected return on this investment. So this expected return of 13%, that's the mean, and the standard deviation is 11.22%. Should that distribution be a normal distribution? I know it's not, right? So it's definitely not. It is a left skewed distribution. Should it have been a normal distribution, the meaning would be that with 68% chance, our returns would have been 13 minus 11, so roughly between 2% and 24%, right? So, but as I said, we do not have a normal distribution. We have a discrete random variable, which is left skewed. More likely we will have a 25% return, a higher return on our investment. As a result, the expected return is 13% and a very, very high standard deviation. But that solves our problem, and we are pretty much done.